Welcome back, friends. In this lecture, we are going to discuss about generation of three address code for the assignment statements using SDT. So you can see here, these are the left hand side. We have mentioned the production role and the relevant semantic rules for the production role. So we will take an example. So for that example, we will convert that example into the three address code, okay, by using that semantic rule. So we will have the example like this: x equal to y plus minus y plus minus z into a. So this is our example. You know that this is not a three address code. So this is an assignment. For this assignment statement, we will be uh, converting the three address code by using the SDT. Okay, so this is our semantic rule. You can see here for the production rule S tends to ID equal to E. So P equal to lookup of ID dot name. If P is not equal to null, then emit P equal to E dot place else error. The meaning is, so here the meaning is the lookup is the operator that is used to check whether this identifier is available in the symbol table or not. If the identifier is available in the symbol table, then that will be given to the pointer P. Okay, that will be given to the pointer P. This pointer P will constitutes the value of this identifier. Okay, this pointer P will constitutes the value of this identifier, and that will be given as an output called P equal to E dot place. This E dot place will be having the value of that identifier, which is pointed by this pointer P. Okay, so remaining things are same what we have discussed in the previous lectures. So for generation of three address code using SDT for various parameters. So here E tends to E1 plus E2 means, so E dot place equal to new temp. Emit is nothing but the keyword is used to produce the output. Okay, it will produce an output. E dot place equal to E1 dot place plus E2 dot place. The same thing is applicable for E1 star E2. The next is the production rule. E tends to minus E1. So it is an unary minus operation. So how it is mentioned is E dot place equal to new temporary variable. So which will produce an output emit. So E dot place equal to U minus E1 dot place. So the next thing is E tends to open parenthesis E1 close parenthesis. So it will be given as E dot place equal to E1 dot place. Here open parenthesis and close parenthesis is used just for an grouping purpose. So no other specific operation is mentioned here. Then finally E tends to ID. So this is also here also the lookup operator will be used in order to identify whether the identifier is available in the symbol table. If the identifier is available in the symbol table, then the address of its of the identifier will be given to the pointer. Then the pointer will go to that particular, pointer will point that particular address, and the identifier's value will be given to the E dot place. Okay, so these are the some general description about the semantic rule. Now we will see how to generate the three address code for this particular expression. Okay, so first we have to draw the annotated parse tree. So we need x, this is the assignment operator, x equal to something. So some values there. So we will be having this first production rule, s tends to id equal to e. So s tends to id equal to e. Okay. So now so you see here, this is ID and equal to, and this entire portion is E. We have to mention like that. Then inside this E, how many operators are there? Plus operator is there, minus operator is there, and multiplication operator is there. So, and we are dividing these things into two parts. One is this part is one thing, and star A is another part. So E star A. Okay. So E tends to, this production rule will be used. E tends to E star E. Okay. After that, this E star E. So you leave this particular star. Now you concentrate on this open parenthesis and close parenthesis. For this, what is the production rule? E tends to open parenthesis, E1, close parenthesis. Open parenthesis, E1, that is E, then close parenthesis. Okay. Now, this E again can be mentioned with plus operator, that is E tends to E plus E, E tends to E plus E, then we need the minus operation. So E tends to minus E, E tends to minus E, then everything is mentioned with ID, tends to ID, E tends to ID, then E tends to ID, then E tends to ID. Now these IDs are mentioned with all this alphabet, all these characters mentioned as an identifier. This identifier is mentioned as with X, and this is mentioned with Y, and this is mentioned with Z, and this is mentioned with A. Now you can see here we have created the unordered parse tree X equal to open parenthesis Y plus minus Z close parenthesis star A, multiplication operator A. Now we have created the unordered parse tree. Now we have now we want to create the 4 address statements. We have to create the 4 address statements. Okay. Sorry, 3 address statements. So the output will be, so I will mentioning the output here. Okay. So the output will be, okay, you see here. So now we have to check from the top-down parsing technique. And after that, if there is no change means we have to evaluate from the bottom up. So first, you can see here, we are starting from the start symbol yes. So ID. So if you want to conclude this yes, we can substitute, we can evaluate this ID now, but the entire portion of the right hand side has to evaluate it in order to get this E, so that only we have to, so that only we can evaluate this yes. So we will start from here. So there is no, so you can see here yes tends to ID. This can be derived, this can be reduced, but in order to get the value, we have to reduce this also. So this reduction can be done from the left and right child of this particular E. So again, you have to check with the E tends to open parenthesis. No, there is no production called E tends to open parenthesis. There is only E tends to open parenthesis, E close parenthesis. So it cannot be reduced. Again, E tends to E, that also cannot be reduced. So, but you can see here E tends to ID can be reduced. Okay, E tends to ID can be reduced. So P equal to lookup of ID dot name. So here ID dot name is the identifier Y is available in the symbol table. So we are mentioning this E dot place equal to P. So what is P? E dot place equal to, the P is Y, that has been mentioned here. E dot P equal to Y. Now in order to evaluate this E, we have to evaluate this. So again, we have to start here. E dot place equal to, so what is P here? Z. Okay. Now you come here, this production rule E tends to minus E. E tends to minus E. So the meaning, so what they have given, the semantic rule given as E dot place equal to new temp. So I am mentioning this new temp as T1. And the next step is emit. Emit means produce the output. So I am mentioning, so I am going to produce the output as, what is E dot place? E dot place equal to T1 equal to U minus what is E1 dot place? E1 dot place is Z. That has been mentioned. Now we can reduce this E with the production. E tends to E plus E. So what is E tends to E plus E? The semantic rule is E dot place equal to again new temp. New temp is T2. So T2 equal to, so why I'm mentioning the T2 here? Because in the next step it is mentioning emit. So emit means produce the output. So E dot place. So emit E dot place is T2 equal to E1 dot place plus E2 dot place. What is E1 dot place? Y plus E2 dot place is T1. Okay. Now this portion has been completed. Now this can be reduced with E tends to open parenthesis, E close parenthesis. So just what is the semantic rule? No, E dot place equal to E1 dot place. That's all. E dot place equal to E1 dot places. That is T2. Now go to this part. So again, E tends to ID can be reduced. So what is semantic rule? P equal to lookup of ID dot name. So the lookup operator will look for the identifier value. Here identifier value is there in the symbol table. That is A. Now this A's address will be given to this pointer P. Okay. So now E dot place equal to P. So in the address, the value A will be present. So that E dot place equal to A. So E dot place equal to A. Okay. Then E tends to E star E. E tends to E star E is again new temp. E dot place equal to generating the new temp, that is T3. So T3 equal to, why I am mentioning T3 here? In the next step it is mentioned as emit. So T3 has been given as an output here. T3 equal to that is E dot place equal to T3. Then E1 dot place. What is E1 dot place? T2 star. Star is mentioned here. Okay. Star is mentioned here. Then E2. What is E2 dot place? That is A. E2 dot place is mentioned as A. So now this particular thing has been evaluated. Now finally, we can reduce this production rule. S tends to ID equal to E. S tends to ID equal to E. So what is the semantic rule? P equal to lookup of ID dot name. So the lookup operator identifies the identifier ID here. What is the identifier here? X. So that is mentioned as P here. So we have to emit. Emit means produce the output. That emit P equal to, so emit X equal to, P is nothing but X here. X equal to E dot places T3. E dot places T3. So this is the relevant tree address code for this particular assignment statements. I hope you have understood. So this can be mentioned clearly with the help of this annotated parse tree and the semantic rules. Okay. Now you can see here this T1 will be mentioned for this minus Z, then canary minus Z, then T2 means Y plus T1. So Y plus T1, this Y plus, that is T2. Then T3 is nothing but T2 T2 into A. So this entire portion into A and X equal to T3. Okay. So I hope you can understand this assignment statement, understand the generation of the three address code for this assignment statement. Thank you.